Hi, I'm an old guy and I do maths. Today we're going to have a look at parabolas, and they are generated by quadratic equations. And we're looking at parabolas specifically generated by quadratics, in this form, ax squared plus bx plus c. And we've got an example of one here, x squared plus 5x plus 6. Now, in order to graph something like this, we need a y-intercept and some x-intercepts if they exist. It so happens that for this equation there are x-intercepts and they're easy enough to find. But the easiest thing to find is the y-intercept. It is this number here. So that's our first piece of information. To find the x-intercepts, what we have to do is we have to factorize this equation. And in factorized form, it looks like this. Now, how did it get from here to here? We took the factors of 6 that add to 5. Now, the factors of 6 that add to 5 are 3 and 2, which you can see here. And that is how we factorized this and got it into this form. Now, one more step. We need to make each of these brackets equal 0. Null factor law. You may have heard of that. Anyway, so here we go. X plus 3 equals 0, so x will equal negative 3. X plus 2 equals 0, so x must equal negative 2. These are the x-intercepts. Okay, so let's graph what we've got. We've got the y-intercept, which we got from here. The x-intercepts, we decided that the values on the x-axis were negative 3 and negative 2. So they are here, and their coordinates are negative 3, 0 and negative 2, 0. And we got those from factorizing this and making each of these brackets equal 0. That, I think, is reasonably straightforward. I chose a nice, easy parabola, nice, easy quadratic to work with, and I think that if you just memorize the process, so you go looking for the y-intercept if you've got your quadratic in this form. Second step, factorize it. Third step, make each of these brackets equal 0, and you'll get the 3 points or the 2 points or the 1 point of interest on your graph. Now, we're going to go after the turning point. So the first thing that we're going to look for is the x-coordinate of the turning point. We're going to use the same equation, so we're dealing with the same graph. Now, our equation is in this form, and we have our original equation, which is y equals x squared plus 5x plus 6, and I've sort of rewritten it here. I've rewritten the stuff that's of interest to us. Y equals 1x squared plus 5x. This is the y-intercept, it's c. We're not interested in that for our purposes here. We're just interested in these two parts of the equation. Now, a is the coefficient of x squared and b is the coefficient of 5x. So of x, it happens to be 5. So a equals 1, b equals 5. Now, there's a little formula for finding the midpoint on the midpoint between the two x-intercepts on a parabola. It also corresponds to the axis of symmetry. And that formula is this. So it is negative b, so negative 5 over 2 times a. So the x-coordinate of the turning point of this graph is negative 5 over 2, negative 2.5. Now, you can also do this by inspection. You're looking for the halfway point between negative 2 and negative 3, and it's really simple. It's negative 2.5. So why bother with the formula and all of the trouble that's involved with that? Well, sometimes the numbers just aren't so pleasant. Let's put it that way. So I chose a really pleasant quadratic to work with, and the result is that hopefully it looks nice and simple. So just to recap, we take this number, put it there, make it negative. We take this number, put it there, multiply it by 2, and that gives us the x-coordinate of our turning point. And I've written it in down here, negative 5 over 2. We have the other points of interest, which we've already worked out, and we have a blank space here, which means that we must be going to look for the y-coordinate. Okay, let's go and do that. And here we are. The x-coordinate of the turning point, the y-coordinate of the turning point, y-coordinate. The x-coordinate we already know, we worked it out on the previous page. X is equal to negative 5 over 2. Right. So now we're going to go to work and find the y-coordinate. There are two ways of doing this. We can substitute this value into our equation. Now our equation, you must be getting sick of the sight of this, is y equals x² plus 5x plus 6. So wherever there is an x in here, we will substitute this number. And this is what it looks like. Y is equal to negative 5 over 2 squared plus 5 times negative 5 over 2 plus 6. You can bang this into a calculator if you like. It's probably easier to do that. Anyway, the answer that you'll get is that y is equal to negative 1/4. That is our y-coordinate of the turning point. So that's method A. That's the one you learn about at school. Here's another one, and sometimes it's simpler. You take the factorized form of the quadratic. Now the factorized form that we had was x plus 3, x plus 2, just to remind you. And we do pretty much the same thing. We put negative 5 over 2 in here where x stood. And you can see that over here. So here's the factorized form, x plus 3, x plus 2. And where x stood, we put negative 5 over 2 in each of them. Now, negative 5 over 2 is negative 2.5. Negative 2.5 plus 3 is a half, sorry. It is a half. 3 minus 2.5 is a half. Negative 5 over 2 plus 2 is negative a half. So, the value of this set of brackets here is a half. The value of this set of brackets is negative a half. And because they're together like this, we have to multiply them. When we multiply them, we get negative 1/4. We get the same answer that we did up here. So this is an alternative method. And this is our quadratic that started out as x² plus 5x plus 6, fully and completely graphed. We have the y-intercept, which we got by just looking at the equation. We have the x-intercepts, which we got from factorizing the equation. We have the x-coordinate of the turning point, which we got by applying this formula. Negative b over 2a, or by simple inspection, halfway between negative 2 and negative 3. And finally, we have the y-coordinate of the turning point which we got from one of these two methods. Okay, now that's a thorough investigation of how to graph every point of interest on a parabola in the form of ax² plus bx plus c. I hope that was helpful. See you next time. Bye.